Welcome to another video on Quant interview series. Candidates are often challenged with advanced probability, statistics, and mathematical analysis questions that test both theoretical understanding and practical problem-solving skills. In this guide, we delve into real quant interview questions asked by these top firms, providing detailed explanations, step-by-step solutions, and insights into the key concepts involved. The Fourier transform is a cornerstone in quantitative finance, signal processing, and physics. A common question in quant interviews is to compute and explain the Fourier transform of a Gaussian function, exploring not only the solution but also the underlying concepts. This question comes from Quantlab. They asked about the Fourier transform of a Gaussian, a function of the form e to the minus a x squared. Let's unpack it step by step, making sure you see the why behind each move. First, what's the Fourier transform? At its core, it converts a function into components based on frequency. You'll see it in physics, engineering, even in finance for equations like Black-Scholes. The formula here is f of k equals the integral of f of x times e to the minus 2 pi ikx over all x. This takes a function and rewrites it in terms of how much it oscillates or varies. Let's set up our calculation. Plug in our Gaussian, e to the minus ax squared, into the Fourier transform definition. We're integrating that function times e to the minus 2 pi ikx. The main goal now is to simplify this integral so it's something we can work with. Often by combining exponents and making a substitution, we simplify the expression as shown here. Next, we use a classic trick, completing the square. This lets us rewrite the messy exponent into a neat squared term plus a constant, making the integral much simpler to evaluate. If you've studied Gaussian integrals, this move should look familiar. We take out the term independent of x outside the integral. This clever rewrite separates variables, making the next integration much more manageable. After rewriting, we make a substitution. Let's call the new variable y equals x plus pi ik over a. This doesn't change our limits. Now, integrating e to the minus ay squared across all y gives us a well-known result, the square root of pi over a. So, putting it all together, our Fourier transform comes out as another Gaussian up to a scaling factor. The final answer is elegant. The Fourier transform of a Gaussian is just another Gaussian, up to scaling. This self-similarity is why Gaussians are so fundamental in probability and signal work. No matter how you transform them, the form remains. Techniques like completing the square are powerful tools for integrals you see in quant interviews. Next, let's head to a classic SIG interview question. Imagine you and I each flip a fair coin 3 times. What's the chance we land the same number of heads? It's a simple setup but a great test of probability, binomial calculations, and understanding of independence. Let's break it down. Each person, independently, can get from 0 up to 3 heads. The probability that one person gets k heads is given by the binomial formula. Since both are independent, the chance both get the same k is just the square of the probability for that k. We'll add across all possible k values. Let's denote the number of heads you get as x, and the number of heads I get as y. Both x and y are independent and identically distributed, each following a binomial distribution with parameters n equal to 3 and p equal to 0.5. The probability that both get the same number of heads is the sum of product of p of x equal to k and p of y equal to k. For a binomial distribution, we can write this as 3 choose k times 1/2 cubed. Solving this expression by putting the values for k starting from 0 and going up to 3, we get the final answer, which is 5 over 16 or 31%. That's it for today's walkthrough. Thanks for joining me in breaking down these real quant interview questions. If you found this helpful, check out datalooper.com for more articles and tutorials on quant, data science, ML, and AI. And don't forget to subscribe so you never miss a new video. Good luck with your interview prep.